Let's try to understand these and many more observations by studying the properties exhibited by the free surface of a liquid. The bed cover lying on the ground is not stretched and hence does not have any tension on being pulled equally from all corners. It gets stretched and develops a tension. The free surface of liquid also behaves in a similar manner, like a stretched membrane, and supports the weight of the water strider and that of an iron needle. To understand the cause of surface tension, let's study the forces acting on the water molecules inside the drop. The molecules deep inside the drop experience a force of cohesion, equally in all directions by the neighboring water molecules. Hence, no resultant force acts on such molecules. A molecule on the surface is surrounded by water molecules on inner side only, and thus experiences a resultant inward force due to cohesion. The surface molecules thus tend to get pulled back into the liquid to attain a state of minimum energy. It does so by minimizing its surface area. Since sphere has the least surface area for a given volume, the water droplets are spherical in shape. You can see the water droplets assume spherical shape on waxy surfaces, such as leaves or waxed cars, from the same reason. A metallic frame having a flexible string, as the sliding arm is dipped in a soap solution, a liquid film is formed. As the flexible wire is pulled outwards, the shape of the film is expected to get altered as shown. Contrary to the expectation, the string gets pulled in form of circular arcs. Since for a given perimeter, a circle has the largest area, the flexible wire assumes arc shape to minimize the surface area by excluding the circular portion from it. Increasing the surface area of the film increases its surface energy, and the film tends to contract back in order to minimize this change. When a brush is dipped in paint, its bristles spread out and move freely. On taking the brush out of the paint, the bristles come closer and stick to each other in order to minimize the surface area of the liquid film formed between the bristles. When the lower end of a thin glass tube is dipped in water, the water rises in the tube to a certain height. Let's study the forces acting on the small portion of the free surface of the liquid. Since the force of surface tension tends to minimize the area of the free surface, it acts downwards along the tangent to the liquid meniscus at the point of contact. The force S, acting along the surface of contact, pulls the tube downward. The tube in turn exerts an equal reaction R on the liquid meniscus in the upward direction, which can be resolved into rectangular components. For diametrically opposite points, the horizontal components will cancel out and the vertical components will add together to lift the liquid in the capillary. This continues till the upward force is balanced by the weight of the liquid column raised. When two identical capillary tubes are placed, one in cold water and the other in hot water, the hot water rises to a lesser height than cold water. As the temperature of a liquid increases, its molecules start moving more vigorously, and the force of cohesion between them decreases. Consequently, the surface tension of the liquid decreases, and the meniscus appears flattened. It is for this reason that hot water is a better cleaning agent. Lower surface tension makes it a better wetting agent, as it gets spreads more to get into pores and fissures. Recall the needle that floats on the water surface. When a drop of liquid detergent is poured into the water, the needle sinks. Let's understand how detergents affect the surface tension of water. A detergent contains hydrophobic molecular chains and hydrophilic heads. When the detergent gets dissolved in water, the hydrophilic heads of the detergent molecules get attached on the water surface and the hydrophobic tail avoids it. This effectively reduces the cohesion between the water molecules, and as a result, the surface tension of the water decreases. For this reason, the upward force due to surface tension could no longer support the weight of the needle. It's easy to blow bubbles with soapy water and not the tap water, as the soap solution with a lower surface tension is able to spread over a larger area than ordinary tap water. For the same reason, a hot soap solution is preferred for cleaning heavily greased clothes, since the detergent reduces the surface tension of water, which is decreased further on heating. The detergent solution spreads over a larger area and washes the clothes more effectively.